All right, let's just jump right into it. It feels like every couple of months, a new AI model drops, and it comes with these massive promises to completely change how we write software. The claims are huge, the benchmarks look incredible, and, the hype is just off the charts. We're talking about AI that doesn't just, finish a line of code for you, but can actually design, debug, and maybe even deploy whole applications. But what's really going on under the hood? And this really is the question on everyone's mind, isn't it? This headline comes from a deep dive into OpenAI's latest model, GPT-5.2. It's provocative, it's a little scary, and it gets right to the heart of what everyone in tech is both excited and anxious about. Is this the one? Is this the tool that finally changes the game for good? Well, to even start to answer that, let's look at just one number, 80%. That's the score GPT-5.2 got on a benchmark called SWE Bench Verified. And look, this is not some simple little coding puzzle. This is a test where the AI has to solve real, messy, complicated bug reports straight from GitHub, all by itself. Getting an 80% success rate on that, well, that's a massive deal. It kind of makes you think the hype might be real after all. So yeah, the benchmarks are super impressive and the marketing is slick, but that's only one piece of the puzzle, right? So in this explainer, we're going to try to cut through all that noise. We're going to look at this from 3 different angles. We'll start with the promise, then we'll dig into the hard science behind these things, and finally we'll hear from the actual developers using these tools every day. Okay, first up, the promise. What is GPT 5.2 supposedly bringing to the table that has everybody talking? The big idea here is that we're looking at a totally new era of AI, one that acts more like an agent, doing things that go way beyond just spitting out code. And when you look at the list of capabilities, you see what they mean. It's not about writing small functions anymore. We're talking about an AI that can find and patch security flaws on its own. It can look at a rough sketch of an API and then go and design it. It has this massive 256,000 token context window. Think of that as its short-term memory, which means it can read and understand an entire codebase at once. Plus, they claim it's 30% more factually accurate than the last version. And you can see that leap in performance right here in the numbers. That SWE bench score we talked about, it jumped from 76.3% to 80%. On something called GPQI Diamond, which is basically graduate-level programming questions, it climbed over 4 points. These aren't just small improvements. This looks like the pretty significant jump in raw problem-solving ability. So how are they doing this? Well, the secret sauce is supposedly in the architecture. It's running on an advanced model that uses something called Mixture of Experts, or MOE. The easiest way to think about it is like having a whole team of specialized doctors instead of just one general doctor. For any problem you give it, the model intelligently picks only the most relevant experts to work on it, which makes the whole thing way more efficient, up to 11 times faster, they say. The promise is clear. It's smarter, it's faster, it's a better coding partner. But now, let's just pump the brakes for a second. Let's leave the glossy product announcement behind and step into the research lab. Because a really important new paper just came out, and it puts a huge asterisk next to all this hype. It points to a fundamental problem that has nothing to do with fancy architecture and everything to do with what these models eat. To really get what they're saying, you have to understand this concept called scaling laws. They're basically the rules of the road for building AI. They're formulas that help predict how much better a model will get if you make it bigger or if you feed it more data. And for a long time, the assumption was that the scaling laws that work for language models, like chatbots, would work just fine for code models too. But here is the bombshell from the paper. It turns out that assumption was completely wrong. The researchers found that code is just fundamentally different from plain English. The bottom line is this: code is way, way more data hungry. To get the same amount of improvement, a code model needs a ridiculously larger amount of data for its size compared to a language model. And this graph from the paper says it all. See that green line shooting upwards? That's for code models. The other lines are for natural language. As you throw more computing power at the problem, the amount of data you need for your code model just skyrockets. It's on a completely different trajectory than language. They're not even playing the same sport. This slide really drives that point home. On the left, you've got the performance landscape for code, and on the right, for language. See how the blue surface for code on the left is so much steeper? That means you can theoretically get to a better result. But to climb that incredibly steep hill, you need to burn way, way more fuel. You need so much more data to make progress. And that brings us to the big reality check from the science. The main thing holding us back from creating a true superhuman coding AI isn't our ability to build a bigger model, a bigger brain. It's the simple brute force problem of finding enough high-quality code in the world to feed it. We might actually be running out of data. So, we've got the incredible hype on one side, and this really sobering science on the other. But what happens when you put these powerful, data-hungry, and honestly pretty complicated tools into the hands of real developers? Let's take a look at what they're actually saying online about using this stuff day to day. Well, the first thing you realize is just how complex it is. It's not just one tool, it's a whole family of them. You've got Max Extra High for tough problems, Max for normal stuff, Mini for speed, Low Fast for simple code. It's like a really confusing menu, and developers are left trying to figure out which fork to use for which course. And this, of course, leads to some pretty intense debates. You've got one person saying, hey, Codex is way faster, it makes sense to use it. But then someone else pushes back, saying the specialized model is actually worse at thinking. They say, I don't really need a model whose thinking is just reciting its next step. It's this classic trade-off. Do you want speed or do you want quality reasoning? But here's the part that's most revealing. Users are confused about how it even works on a basic level. Here you have developers arguing about whether the AI's thought process from one step carries over to the next, especially if you switch between these different models. And the fact that even really experienced people aren't sure how it's supposed to work, that tells you there's a huge gap between the advertised power and the actual day-to-day user experience. Okay, so we've looked at three very different sides of this story. We've seen the incredible promise, the data-hungry science, and the kind of messy, confusing reality of using it. So what does it all mean when we put it all together? Let's just quickly recap. First, the hype tells us we're right on the edge of having AI that can solve really hard real-world coding problems. But then, the science warns us that progress is hitting a wall, this massive need for more training data that might not even exist. And finally, the reality on the ground shows that developers are wrestling with tools that are complex, confusing, and not always clear. So, what's the takeaway here? The future of AI in coding isn't just about building bigger models. The real challenge is solving this data problem. And just mixing in more plain English text, as the research shows, isn't a real long-term fix. And this also means that, for the developers actually using these things, the best tool isn't going to be the one with the highest score on a benchmark. It's going to be the one that's the most predictable, the most understandable, and the easiest to work with. Which brings us all the way back to that first question. Will AI make developers obsolete? It seems like that's just the wrong question to be asking. The real question, the one that comes out of all this, the hype, the science, and the real-world experience, is much more interesting. It's how are we, developers and AI, going to build the future of software together?